Hey everyone, and welcome to our deep dive on black holes. Today we're going to be checking out this really cool YouTube video from Ashkar Podcast that explains black holes, in a way that's like surprisingly easy to understand.
Yeah, they did a great job.
Yeah. So get ready for like some serious mind-bending stuff as we go from, Einstein's early theories all the way to that crazy first image of a black hole.
You know what's so interesting about black holes is they just totally capture our imagination. They kind of seem like these scary cosmic monsters, but the truth is way more complex, even awe-inspiring, I think.
For sure. So okay, let's start with the basics.
Yep.
What exactly is a black hole?
Okay, so a black hole is basically a region in space where gravity is so strong that nothing, not even light, can escape.
Whoa.
Yeah, and it happens when a massive star collapses at the end of its life.
That's wild.
Yeah.
Wait, didn't even Einstein, the guy who basically rewrote the rules of gravity, have trouble with the whole black hole idea?
Yeah, it's true. Even Einstein kind of doubted they were real at first. His theories, especially the general theory of relativity, laid the groundwork for understanding these things. But he thought they were too bizarre to actually exist.
Mm-hmm.
You have to remember, space-time is like a fabric that can be warped by heavy objects, and black holes just warp it like crazy.
So is it kind of like a cosmic trampoline? The heavier the object, the more it sinks in?
Exactly. That's a great way to think about it. Just like a heavy object makes a big dip in a trampoline, a black hole creates this deep gravitational well in space-time.
Okay, I'm starting to get it.
And this well is so steep that anything that gets too close falls in and can never climb back out.
Not even light, right?
Nope, not even light, which is the fastest thing in the universe.
Yeah.
And that's why we can't actually see a black hole. It's basically invisible.
That makes sense.
But we can see how it affects the stuff around it, like matter and light. It's kind of like a shadow puppet. We can't see the puppet, but we can see the shadow it makes.
Right. Speaking of shadows, I remember seeing that incredible first image of a black hole a few years ago.
Right.
It wasn't just a black void, though, was it?
Oh, yeah. No, it was this bright ring of light around a dark center. We call that ring the accretion disk.
Accretion disk. Okay.
And it's made of superheated gas and dust. It's swirling around the black hole super fast, getting pulled in by its gravity.
So like a cosmic whirlpool.
Totally. And it gets so bright because all that material gets squeezed and heated to billions of degrees as it gets closer to the black hole.
Wow.
That intense heat makes the disk glow and emit all kinds of radiation across the electromagnetic spectrum.
That's insane. Okay, so how do black holes actually form? It sounds like it all starts with stars.
You got it. It all begins with the life cycle of a star. You see, stars are constantly burning fuel, fusing hydrogen into helium in their cores.
Right.
And this fusion creates outward pressure that fights against the inward pull of gravity. But when a big star runs out of fuel, it can't support itself anymore.
So what happens then? Does it just fizzle out?
Not quite. It's more like a huge implosion. The core collapses in on itself really fast. And if the star is massive enough, way bigger than our sun, this collapse can create a black hole.
Oh, wow. So that's why our sun will become a black hole, right?
Exactly. Our sun's not big enough. It'll eventually turn into a white dwarf, which is basically a dense star, but much smaller and way less dramatic.
That's good to know. So we're safe.
Totally.
Okay, so black holes come from collapsed stars, but how many are out there? And are they all the same?
Well, the most common type are constellar black holes. They're formed when single massive stars die. And scientists think there could be millions, maybe even billions of them just in our own Milky Way galaxy.
Billions. That's a lot of black holes.
Mm-hmm.
So are they all out there waiting to swallow us up?
Not really. I mean, a black hole's gravity is strongest near its event horizon, which is basically the point of no return. But as long as we stay far enough away, we're good.
Okay, that's reassuring.
The thing is, black holes come in different sizes. You have the smaller ones, and then you have these supermassive giants that hang out at the centers of galaxies.
Supermassive black holes. What are we talking about here, size-wise?
Imagine a black hole with the mass of millions or even billions of suns all squeezed into a space smaller than our solar system.
Wow.
These supermassive black holes act as gravitational anchors for whole galaxies. They control the orbits of stars and everything else over huge distances.
Hold on. Are you saying our galaxy has a supermassive black hole?
Yep, we do. It's called Sagittarius A, and it's right in the center of the Milky Way, holding everything together.
That's incredible.
Yeah.
So what happens to all the stuff that falls into a black hole? Does it just vanish?
Well, that's one of the biggest mysteries about black holes. At the center of a black hole is what we call the singularity. It's a point where all the matter is compressed into an infinitely small space. And our understanding of physics, completely breaks down at the singularity.
So it's like the ultimate cosmic mystery.
Exactly. We have no idea what happens there. And that's just one of the many fascinating things about black holes. They push the boundaries of what we know about the universe and make us question, like, everything.
My mind is officially blown. So if black holes are these super dense things with insane gravity, why aren't they just sucking up everything in sight?
That's a great question. And it brings us to one of the most important things to remember about black holes. They're not like giant cosmic vacuum cleaners.
Wait, really? I always pictured them that way.
Yeah, it's a common misconception. You see, while they have super strong gravity, it's important to remember that black holes don't just like roam around gobbling things up. Their gravity is strongest near the event horizon, but it gets weaker the further away you are.
So it's kind of like standing near a bonfire. The closer you are, the hotter it feels, but if you step back, it's not as intense.
Exactly. So while, you wouldn't want to get too close, black holes aren't these unstoppable forces of destruction that people sometimes think they are. In fact, they actually play a crucial role in how galaxies are structured and how they evolve.
Okay, so they're not just cosmic villains.
Right, exactly. They have a really important job.
That's pretty cool. But speaking of villains, I got to ask about the event horizon. What happens when something crosses that point of no return? Is it just like game over?
That's where things get really mind-bending. Once something crosses the event horizon, it can never escape. Not even light.
So what is it beyond that point? Is it just like a black void? Or is there something else going on that we just can't even imagine?
It's a total mystery that scientists are still trying to figure out. What happens beyond the event horizon is something we can only guess at for now.
It's like the ultimate cliffhanger.
I know, right? We're left wondering what secrets are hidden inside these crazy objects.
And that's what makes black holes so captivating. They challenge what we think we know, push the limits of our understanding, and remind us that there's still so much out there that we don't know about the universe.
Absolutely. They're a constant reminder of how much we still have to learn.
For sure. Yeah, it really is incredible to think about how something that seems so destructive could be so important to the universe. But I'm still trying to picture how a black hole, with all that gravity, can actually help keep a galaxy together.
Well, it's all about balance, Think of it like this huge cosmic dance.
Okay.
The supermassive black hole in the center of a galaxy pulls everything in with its gravity. But the stars and everything else in the galaxy are also constantly moving. They're orbiting around that center.
So it's like this delicate balance between the pull of the black hole and the momentum of all the stars.
Exactly. Kind of like a solar system, where the planets orbit around the sun, but like way bigger. The supermassive black hole's gravity keeps everything in check, so the galaxy doesn't just fly apart.
Makes sense.
Yeah.
But what about those smaller stellar black holes we talked about? Do they, play a part in this cosmic dance, too?
Yeah, definitely. Even though they're much smaller than the supermassive ones, they still have a pretty big gravitational pull on the stuff around them. They can interact with other stars, form binary systems, and even crash into each other. And when that happens, it creates these ripples in space-time that we can detect here on Earth. We call them gravitational waves.
Wait, gravitational waves? Those are actually real. I thought they were just like a theory.
Yeah, they were a theory for a long time. But in 2015, scientists actually detected gravitational waves for the first time. It was a huge deal because it proved one of Einstein's biggest predictions.
That's crazy.
These waves are like ripples in the fabric of space-time itself, and they're caused by these super violent events like black hole collisions.
Wow, so black holes aren't just shaping galaxies, they're also creating these cosmic ripples that travel across the universe.
It's pretty wild, right? And it just shows that black holes aren't these like static things. They're constantly interacting with everything around them, and they're playing a huge role in how the universe evolves.
You know what? I'm starting to see black holes in a totally new light. They're not just scary monsters hiding in the dark. They're actually really important to the big picture.
Yeah, a lot of people have that same realization when they start learning more about black holes. I mean, They can be scary and mysterious, but they're also incredibly fascinating and crucial to the universe we live in.
So true. Okay, so we've talked about how black holes form the different types and their role in the universe, but I gotta be honest, I'm still hung up on that whole event horizon thing. What actually happens when something crosses that line? Is it just like instant annihilation?
Well, that's a question that's been bugging scientists for decades, and we still don't have a definite answer. But what we think is that once something crosses the event horizon, it can't escape, and it gets pulled towards the singularity at the center of the black hole.
And just to remind me, what exactly is the singularity again?
Oh, yeah. So the singularity is basically a point of infinite density. All the matter that's fallen into the black hole gets squeezed into this infinitely small space.
Right.
And all our laws of physics just go out the window at the singularity. We can only guess what might be happening there.
So it's like the ultimate unknown, like a giant cosmic question mark.
Exactly. And it's that mystery that makes black holes so intriguing. They make us push the boundaries of what we know and explore the limits of our understanding.
And speaking of pushing boundaries, there's this whole idea of black holes being like portals to other dimensions or even time travel. Is there any truth to that, or is that just science fiction?
It's definitely an area where scientists are doing research and there's lots of speculation. But honestly, we don't have enough evidence to know for sure. I mean, the crazy gravity and warped space-time around a black hole could totally create some weird effects. But whether those effects would lead to things like wormholes or time travel is still a big debate.
So he's got to wait and see.
Basically, yeah. Who knows what kind of amazing discoveries are waiting for us as we keep studying black holes.
Well, this deep dive has definitely left me with more questions than answers. But that's a good thing. It's awesome to think about how these objects that were once just theoretical ideas are now being studied and observed in more detail than ever before.
Yeah, it really shows the power of human curiosity and our drive to learn. And every new discovery gets us a little closer to understanding what these mysterious objects really are.
Absolutely.
Yeah.
We got to give a shout out to Ashkar Podcast for making that super informative and engaging video that we've been talking about today.
Yeah, for sure.
If you're listening and you're as fascinated by black holes as we are, definitely check out their full video. It goes into way more detail and has some awesome visuals that really bring the science to life.
Totally. It's an awesome resource for anyone who wants to learn more about this stuff. And who knows, maybe it'll spark your own curiosity about the universe and inspire you to explore some of the mysteries out there.
I love that. So well said. That's a great point to wrap things up. The universe is full of incredible things, and black holes are just one example of the amazing stuff that's out there waiting to be discovered and understood. I mean, it's kind of crazy to think that something as big and powerful as a black hole can come from just one star dying.
Yeah, it's pretty wild. And remember, not all stars end up like that. Our sun is going to turn into a white dwarf eventually.
Yeah, right. Way more chill. But thinking about all this black hole stuff makes you wonder what happens to a black hole in the end. Do they just exist forever?
That's a really interesting question. And it brings us to something called Hawking radiation.
Hawking radiation.
Okay,
I know Stephen Hawking, but what is that exactly?
So basically, Stephen Hawking thought that black holes aren't actually completely black. He said that they actually give off a little bit of radiation because of quantum stuff happening near the event horizon.
Quantum stuff. Here we go again.
Yeah, it gets a little complicated. But basically, the idea is that these virtual particles are always popping in and out of existence all over the universe, even near black holes.
Okay.
And sometimes one of these particles might appear right outside the event horizon and escape, while its partner falls into the black hole.
So it's like one particle gets lucky and the other one gets trapped.
And you could say that.
Yeah.
And when the particle escapes, it takes a little bit of the black hole's energy with it. And over a really, really long time, this has actually caused a black hole to shrink and eventually disappear.
Wait, black holes can disappear?
In theory, yes.
Yeah.
But it would take so long. Like for a normal stellar black hole, it would take longer than the entire age of the universe.
Wow. So not something we'll ever see.
Probably not. But it's still pretty cool to think about.
Yeah, it definitely changes how you think about black holes being these permanent things. So if they can evaporate, does that mean they're not the final stage for matter and energy?
That's something physicists are still debating. Some theories say that all the information about the stuff that falls into a black hole might not be lost.
Okay.
Maybe it's somehow saved, encoded in the Hawking radiation that escapes.
So the black hole keeps a record of everything it swallowed.
Yeah, it's an interesting idea.
Yeah.
But it's still just a theory for now. We don't really know what happens to information and matter inside a black hole. It's one of the biggest mysteries in physics.
Man, this deep dive has been a wild ride. We've talked about Einstein's theories, quantum mechanics, black holes evaporating. It's amazing how much we've learned about these things. But there's still so much we don't know.
I know, it's crazy, right? Black holes are like the ultimate frontier for science. They force us to rethink everything we thought we knew, and they push us to keep exploring and asking questions about the universe and our place in it.
Big shout out to Ashkar Podcast for making that awesome video that got us thinking about all this stuff.
Yeah, seriously. If you're listening and you want to learn more, definitely check out their full video. It's got even more crazy details and some really cool visuals that make it all come to life.
Definitely. And who knows, maybe this will inspire you to make your own discoveries about the universe.
That's the beauty of science. It's all about exploring and learning new things.
Couldn't have said it better myself. So keep looking up, keep asking questions, and never lose that curiosity about the world around you. And if you're hungry for more awesome content like this, make sure to like, share, and subscribe to Ashkar Podcast for all the latest updates.